How the U.S. Navy manages 6,000 sailors' trash aboard aircraft carriers at sea? Here is the secret system that stops 6,000 sailors from turning the deck into a landfill. Imagine a floating city the size of a small town, with 6,000 people, all eating, sleeping, and throwing things away, every single day. Now imagine keeping that entire city clean while it's steaming through the ocean, under mission pressure, with no garbage truck in sight. Tonight, we follow the secret routines that stop trash from piling up into a nightmare. Giant compactors that crush mountains of waste, strict zones where even a banana peel can start a chain reaction, and crews working around the clock to prevent food, fuel, and plastic from becoming ship-breaking hazards. But there's a problem nobody talks about. A hidden bottleneck that can turn a tidy ship into a ticking environmental and safety time bomb. What happens when the system breaks? And could one bad day at sea turn an aircraft carrier into a catastrophe? Stay with me. The answer will shock you. For decades, the ocean was the Navy's trash can. Anything unwanted, plastic forks, soda cans, greasy rags, even broken electronics, went straight overboard, vanishing in the ship's wake. That all changed with one international agreement. In 1988, MARPOL Annex 5 made it illegal for any vessel to dump plastics at sea. The U.S. Navy, a signatory by 1987, faced a new reality. The world was watching, and the old ways were over. Suddenly, every ship, especially the floating cities of the carrier fleet, had to account for every scrap of plastic, every wrapper, every disposable cup. The impact was immediate and dramatic. Navy environmental compliance officers, once a quiet presence, became the enforcers of a new order. They walked the decks with checklists, scanning for stray bits of plastic, warning division chiefs that even a single infraction could bring legal trouble and international headlines. Internal memos from the late 1990s show bitter arguments between compliance officers and senior officers worried about losing operational flexibility. Some commanders argued that strict rules would slow down missions and endanger readiness. Others insisted that the Navy had a duty to lead by example, not just in firepower, but in stewardship of the sea. The Navy's response was sweeping. Plastic waste processors, giant machines that could shred, melt, and compress plastic into dense, odorless pucks, became standard equipment. These pucks, sometimes called hockey pucks by the crew, were bagged, tagged, and stored in special rooms deep in the ship, waiting for the next port call. No one liked losing precious storage space to garbage, but the alternative was worse, risking fines, diplomatic incidents, or even criminal charges for illegal dumping. Every carrier now had to track its waste output with the same precision as its ammunition and fuel. The rules didn't stop at plastics. MARPOL Annex 5 also set strict limits on what else could be thrown overboard and where. Food waste and paper could only be discharged after being pulped, and only when the ship was at least 3 nautical miles from land. Metals and glass had their own zones and restrictions. For the first time, the Navy's waste management was dictated not just by tradition or convenience, but by international law and environmental necessity. The era of the open ocean dump was over. In its place stood a complex, rule-bound system, one that demanded new machines, new routines, and a new kind of vigilance. The environmental compliance officer became the ship's conscience, reminding everyone that the world outside was watching, and that even a floating fortress had to play by the rules. Down in the bowels of the ship, there's a place every sailor knows but few ever visit: the trash flat. Here, in a windowless maze of steel, 12 to 16 sailors work 12-hour shifts, 7 days a week, just to keep the carrier from drowning in its own garbage. Every day, 15,000 meals are served: eggs, burgers, noodles, the works. That means thousands of pounds of food scraps, wrappers, and plastic forks start their journey here, dumped into bins that fill up faster than you can say chow line. It's sweaty, noisy, and the air is thick with the smell of old coffee, bleach, and something nobody wants to identify. The crew calls themselves raccoons, half in jest, half in pride. One sailor put it bluntly, "You want to know who keeps the ship running? Not the pilots or the captain. It's us, sweating in the trash room at 2 a.m. Their job is relentless. Bags of garbage come down from every deck, berthing, galley, maintenance shops, and have to be sorted by hand. Plastics in one bin, food scraps in another, metal cans and broken glass in their own corners. Sorting matters. One wrong item in the pulper or compactor can jam a machine, shut down the line, and send trash piling up so fast it threatens to spill into the passageways. That's when the pressure gets real. If the trash flat falls behind, the galley can't serve meals, and flight ops grind to a halt. There's no backup plan. Morale is a strange beast in the trash flat. The work is hot and dirty, and nobody ever says thank you unless the smell gets out of control. But there's a stubborn pride here. The team blasts music to drown out the roar of the compactors, runs unofficial contests to see who can process the most waste per watch, and swaps dark jokes about the trash hacks they invent to keep the machines running. For a lot of sailors, this is their first assignment, a rite of passage that's equal parts punishment and badge of honor. No one signs up for trash flat duty for the glory. But ask any veteran, and they'll tell you, without these sailors, the ship would choke on its own waste in less than a week. Every banana peel, every milk carton, every greasy pizza box is their responsibility. The rest of the crew might not see them, but they feel the results. Clean passageways, hot food, and flight ops that never miss a beat. It's invisible labor, but it's what keeps the floating city alive. Aboard an aircraft carrier, the journey of a single plastic fork is anything but simple. After sorting in the trash flat, plastics are bagged and carried down narrow passageways to the mechanical heart of the waste system. The first stop, the shredder. Here, rigid containers, food wrappers, and utensils are chewed into a uniform mass, stripped of any stray metal or food scraps that could jam the works. The shredded plastic drops into a collection bag, ready for the next stage. Now comes the main event, the compression melt unit, or CMU. Sailors load the shredded plastic into a steel chamber about the size of a large oven. When the chamber is full, the door seals shut. The machine heats up, reaching temperatures high enough to soften the plastic but not ignite it. A heavy ram presses down, squeezing the molten mass into a dense, disc-shaped puck. Each cycle takes between 30 and 45 minutes, longer if the load is mixed or the humidity is high. The finished disc weighs around 5 to 9 kilograms, depending on what's inside. But the process doesn't end there. The freshly formed disc is blazing hot, too unstable to move safely. The CMU's cooling system, a seawater heat exchanger, kicks in. The disc sits under pressure until its temperature drops below 40 degrees Celsius, a weight that can stretch the cycle time if the ship's cooling water isn't flowing fast enough. Only when the indicator gives the all clear can the operator unlock the chamber and remove the disc. Each disc is double bagged and heat sealed to trap odors and prevent leaks. Then it's stacked in a designated storage room, joining dozens of others. On a typical day, the crew produces 20 to 35 discs, sometimes up to 50 during meal surges or flight operations. That's 150 to 250 kilograms of compressed plastic every day. Storage space is limited. If the CMU falls behind, because of a jammed shredder, a cooling glitch, or a surge in galley waste, bags start piling up in the staging area. Overflow means lost space for spare parts or even munitions. In the worst cases, the backlog threatens to spill into passageways, putting pressure on the crew to keep the machines running around the clock. It's a relentless cycle: sort, shred, melt, cool, bag, and store. Every step has to work. When it doesn't, the consequences ripple through the entire ship. One bad batch, one missed cycle, and the floating city starts to feel a lot smaller. On the newest generation of aircraft carriers, the Navy has taken a leap into the future with a machine that sounds like science fiction. A plasma arc system capable of vaporizing the ship's trash. The official name is PAWDs, Plasma Arc Waste Destruction System. Instead of shredding, melting, and storing pucks of plastic, the crew now feeds bags of mixed waste, plastics, paper, oily rags, straight into a sealed chamber. Inside, a jet of superheated plasma, hotter than the surface of the sun, tears apart the waste at the molecular level. In less than a minute, 400 pounds of trash can vanish, leaving nothing but clean gases and a handful of sterile ash. There's no smoke, no smell, and, critically for a warship, no visible heat plume to give away the carrier's position. Old incinerators belched clouds of soot and left behind a trail the size of a small factory. With PAWDs, that signature disappears. The system runs almost silently, tucked away in a compartment smaller than a city bus, monitored by just 1 or 2 sailors at a time. No more round-the-clock crews sweating over jammed compactors or wrestling with leaking bags. One touch on the control panel and the process runs itself. The difference is more than just convenience. With PAWDs, the ship no longer needs to dedicate precious storage space to mountains of plastic discs or wait for a port call to unload garbage. The system can keep pace with the tidal wave of trash from 6,000 sailors, hour after hour, without missing a beat. During high-tempo operations, when every inch of space and every second of readiness matter, that kind of reliability is priceless. For the first time, the Navy can destroy nearly all of its combustible waste on board, in real time, with almost no environmental footprint. Engineers point out that the system's emissions are so thoroughly scrubbed and quenched that not even a thermal camera can spot a trace. The old debate, manual labor versus automation, tradition versus technology, hasn't vanished, but the numbers speak for themselves. On Ford-class carriers, the plasma arc system is setting the new standard, promising a future where the ship's trash problem is solved not with more hands, but with a flash of controlled lightning. Nothing brings the trash system to a halt faster than a jammed compactor or a sudden fire alarm. It starts with a sound, a grinding whine, a clunk, or sometimes just silence when the machine should be roaring. A single pizza box folded the wrong way, or a plastic bag stuffed with metal, can wedge itself deep inside the shredder, seizing the gears and stopping the entire line. Within minutes, bags start piling up in the staging area. The air thickens with the smell of old food and melting plastic. Every sailor in the trash flat knows what comes next. A scramble to clear the jam before the backlog spills into the passageways. But mechanical jams aren't the only threat. Oily rags, tossed in with the wrong load, have sparked more than one fire. The alarm blares, red lights flash, and the crew drops everything, racing with extinguishers through narrow corridors, fighting smoke and panic in spaces barely wide enough for 2 people to pass. Even a small fire is a nightmare at sea. In these moments, the line between routine and disaster feels razor thin. Damage control teams swarm the area, venting smoke, checking for hot spots, and making sure the fire hasn't spread to nearby storage or electrical panels. The rules are clear. One unchecked blaze could threaten the entire ship. Every incident is a reminder. This system is tough, but it's not unbreakable. One wrong move, one overlooked warning light, and the trash that keeps the ship running can turn into the enemy. When the machines go down, the pressure on the crew spikes. Every second counts. Overflow is no longer just a nuisance. It's a threat to safety, readiness, and the mission itself. Overflow isn't just a mess, it's a crisis that can bring a warship to its knees. When the trash system grinds to a halt, the backlog doesn't wait politely in the trash flat. Bags start stacking up in staging areas, then spill into passageways, and, in the worst cases, overflow onto the hangar deck itself. That's not just unsightly, it's dangerous. The hangar is the nerve center for flight operations, packed with jet fuel, ordnance, and a constant flow of crew. Now imagine hundreds of pounds of plastic waste blocking access routes, threatening fire hazards, and choking off emergency egress. In these moments, the normal chain of command snaps into emergency mode. The executive officer, or XO, becomes the decision point. The rules are clear. No plastics or hazardous waste go overboard unless the safety of the ship or crew is at immediate risk. But when storage rooms are bursting and the hangar deck is filling up, the XO must weigh every option. Sometimes, the only solution is to authorize a temporary transfer of waste to auxiliary spaces, supply rooms, even magazine voids, while the crew works around the clock to clear the bottleneck. If all else fails, emergency disposal at sea is possible, but only after the XO, Environmental Compliance Officer, and Commanding Officer sign off, and only with immediate reporting up the chain. Every decision is documented, every risk calculated, because one misstep could mean legal trouble, lost readiness, or worse, a disaster at sea. The line between order and chaos is thinner than most people ever imagine. Arguments between environmental compliance officers and operations chiefs still play out in every ready room and engineering space. One side pushes for zero discharge, maximum automation, and airtight compliance with international law. The other warns that a ship can't risk mission delays just to satisfy paperwork, especially when a trash jam could halt flight operations or force a carrier to break off station. Hacks and shortcuts, from makeshift chutes to off-label trash bags, have been both a lifeline and a liability. Some captains quietly tolerated these workarounds during high-tempo deployments, but after a series of near misses and unsanitary spills, Navy policy now bans all unauthorized modifications. Every trash hack is watched, logged, and, if caught, earns extra duty or reassignment. Modernization is slow and expensive. Retrofitting a Nimitz-class carrier with plasma arc systems takes years, costs millions, and means carving out space already claimed by weapons or supplies. The Ford-class ships get the upgrades first, while the rest of the fleet waits for funding and technical fixes. In the meantime, a single failure in the waistline can still ground flight operations. During a 2015 surge aboard USS Ronald Reagan, galley trash overflow forced a temporary pause in launches until the backlog was cleared. For now, the future is a moving target, a decade-long roadmap of phased plasma rollouts, stricter oversight, and the hope that new tech will finally break the old cycle of crisis and compromise. Every day, U.S. Navy aircraft carriers serve 15,000 meals and produce hundreds of kilograms of waste, numbers confirmed by official Navy logistics reports. The transition from overboard dumping to strict MARPOL Annex 5 compliance in the 1990s forced crews to adopt new roles, build new routines, and rely on complex machines like the CMU and, more recently, the PAWDS plasma system. This documentary has shown the human toll. A handful of sailors sorting, compacting, and monitoring waste around the clock, with real risks when systems jam or overflow. Yet, even with advanced technology, incidents of trash overflow and emergency disposal still occur, and some internal reports on system failures remain classified. The ongoing fleet-wide retrofit of plasma systems is documented, but its full effectiveness under combat conditions is not yet public. What is clear? Every piece of trash aboard is now a matter of environmental law, engineering, and crew safety. The future of waste at sea will depend on vigilance, technology, and the lessons learned by those who work below decks, hour after hour, disc after disc.